Looking for great questions? Here is the YouTube channel for you. Tips on inverse of exponential functions. We will discuss many brilliant questions on logarithms in this particular video. Enjoy the journey with Anil Kumar. Here is a thinking question based on how do we find inverse of an exponential function? As you know, logarithms are inverse of exponential function. So, given an exponential equation, we have to get that log form. The question is from past test paper, and I hope its solution will help many students who are looking forward for advanced level of mathematics. We need to find inverse of the function 3e to the power of 2x. First, we'll understand few concepts, then we'll begin with the solution. So if I try to sketch this particular function, how will it look like? E to the power of 2x is always positive, always increasing, and 3 times will be kind of like this, right? Of course, when x is equal to 0, the point here will be 3, correct? So that could be one of our key points. To find the inverse means that we are going to graphically, if we were trying to figure it out, we would have reflected this on the line y equals to x. And we would have got our result, which could be kind of like this, right? So that could have been our graphical solution. Now let's figure out how do we find algebraically. I hope it's making sense. Well, in case you want to learn directly from me, send an email on globalmathinstitute@gmail.com. In just few classes, you can be an expert on subjects like advanced functions and calculus. Right, so now let's follow the standard method of finding inverse. So we are given that function means f of x, or we can write y is equal to 3e to the power of 2x. First step to find the inverse is to swap x and y. So we are going to write this as x equals to 3 times e to the power of 2y. And then we can isolate what y is. Now at this stage, I'll also like you to look into domain and range of the function. So remember one thing, that as far as the function is concerned, the domain here is x belongs to real numbers, right? So in the first case, we have domain as x belongs to real numbers, right? And the range is that y is greater than 0. Of course, they are real numbers, right? So y also belongs to real numbers. Now, when you swap, the domain and range also swaps, and so for the inverse, now when you find the inverse, for inverse, what is the scenario? Domain now becomes x greater than 0, where x belongs to real numbers, right? And the range is y belongs to real numbers. Y belongs to all real numbers, correct? So no restriction on the y value. However, the domain will have a restriction. As you can see, we have a vertical asymptote here at x equals to 0. So there is a restriction on domain. It makes sense, right? Correct. So let's now move forward. This was an essential step I thought I'll focus on before moving algebraic solution. So let's now continue with our equation, which is x equals to 3 times e to the power of 2y. Idea is to get the value of y. So we'll take log both sides. Whenever you are working on e, take log to the base e, which is natural log ln. So we get ln x equals to ln 3 e to the power of 2y. So we have ln x equals to, apply the properties of logarithms, right? So we can, because this is a product, we can write this as ln 3 plus ln e to the power of 2y. So ln x, ln 3 we can take on the left side, which is a constant, or we can take it later. So I'll write it now. Minus ln 3 equals to ln e to the power of 2y, right? So ln x minus ln 3 is ln x over 3, right? Let me write like this. Now, ln e to the power of 2y means 2y times ln e. Ln e is what? So we get ln x over 3 equals to 2y. Since ln is 1, right? So you see our solution now? We can now isolate y and write down y as equal to half of ln x over 3. Do you see that part? So that is how we can rewrite final answer as ln x over 3 to the power of half. Correct? Which means square root basically. Correct? So you can rewrite this as y equals to ln square root of x over 3. So that becomes your inverse function. So now we'll write in function notation f inverse of x is equal to ln square root of x over 3. Perfect. So that is how we actually get the inverse of the function. And as you can see here, the domain of this inverse function is that x has to be greater than 0 and the range will be y is all real numbers, right? So we get this inverse function equation right there. I hope the steps are absolutely clear. Here is a brilliant question based on logarithms. It has been seen in past test papers, and I hope its solution will help many others. Now, we could take log on both the sides to solve this particular problem. Let's see how. The question here is x to the power of log x equals to 10,000 x cubed. If I take log both sides, it will be log of x to the power of log x equals to log of 10,000 x cubed. On the left hand side, using the power property, we get log of x, as that's the power of x, times log x. And on the right hand side, we have log of 10,000. We can apply the product rule. So log of 10,000 plus log of x cubed. So we have an equation of the form log x whole square equals to log of 10,000, 4 zeros means the number 4, plus 3 times log x. So you see we have equation in logarithms, kind of quadratic equation in logarithms. Now let me make a substitution. Now this is the key strategy here. So select log x equals to some number, let's say p, some variable. In that case, the question becomes p square, bringing the terms together on the left hand side, minus 3p minus 4 equals to 0. You see that? So we replaced log x with p and brought all the terms to the left hand side. Correct? So we get a quadratic equation of the form p square minus 3p minus 4 equals to 0. Now, it's a quadratic equation which you can factor. Minus 4 means 4 times 1, 4 negative. So we can factor this as p minus 4 times p plus 1 equals to 0. That gives us two possible solutions, p equals to 4 and p equals to minus 1. Now, what is p? P is log 4, right? To the base 10. So, we can now rewrite p as log of x equals to 4 and p as log of x equals to minus 1. So, solving this, we get the value of x as 10 to the power of 4, that is one value. And here we get x equals to 10 to the power of minus 1. So these are the two solutions for us in the given scenario. So you could write x as equal to 10, 4 zeros, right? That is 10,000. Or you can write x equals to 1 divided by 10, which is 0.10. Perfect. So that becomes the solution of this particular equation. I hope it makes sense. Now here is logarithms application. Hundreds of videos for you. Try, practice, and master these strategies. Let's begin with the question here, which is if log to the base a of x is p and log to the base b of x is q, then find the value of log to the base a over b of x. So clearly in this question we have changed the base. So you need to apply the change of base formula. Now I've seen that many students do not really understand how do we apply change of base formula. So let us first understand what is this change of base formula, right? So if we have log to the base a of x, we could change this base to anything. Let it be b. In that case, it will be log b of x divided by log b of a. You get the idea. So log b of x and log b of a. So that becomes the change of base formula. Now here there is very interesting thing, and that is if I change the base to x itself, right? If I change the base to x itself, that is, if let's say b base is x, then what happens? If base is x, then we could actually write log of ax as equal to log of xx, right, over log of xa. Now you can see log of xx is 1, so it is 1 over log of x of a. So you know what has happened here? We have literally written log to the base a of x as a reciprocal, right? You see this reciprocal? Now that is a very, very important application from this change of base formula. Now, application of this is what we are going to look into in solving the given problem. So, I hope you have understood the whole concept. At this stage, you can always pause the video, answer the question, and we'll now look into the solution. Well, in case you are interested in learning topics like logarithms or anything for that matter, up to grade 12 students, you can always contact me on email globalmathinstitute@gmail.com. Our students get admission to the best universities in the areas of computer science and medicines, even with scholarship. So one of our students got highest marks in Toronto. Well, now let's include the learnings and solve the problem. Correct. So as I was saying, we need to change the base. So let's begin with log to the base a of or log of x to the base a over b. So let's change the base to what? That is first decision which you need to take. Now, since we are given log ax, it could be log x of a as 1 over p. You get the whole idea. So we'll change the base to x itself. So see what happens. Log of x, right? And in the denominator, we get log of base x of a over b. Now, at this stage, we can apply the second property, which you know, right? Quotient is like a difference, right? So we have now log of x of a minus log of x of b. Makes sense, correct? So as you can see here, we are given log of a of x, not x of a. So we'll write this as a reciprocal, right? Numerator is just 1. Let me change the ink here. Numerator is 1 log of x, right? And in the denominator, we get 1 over log of a of x minus 1 over log of b of x. Makes sense, right? So we kind of flipped it. And now you can further, take common denominators, correct? To get 1 over. So take common denominator means this, right? Log of ax log of bx, correct? And here we get log of bx minus log of ax, correct? And now you can flip and rewrite this. Let's change the ink again. So we get in the numerator log to the base a of x times log to the base b of x over the difference. But the difference is log to the base b of x minus log to the base a of x, correct? We are given the values. Now you can substitute these values, right? These two, and get the result. So the numerator, product of p and q is what we get. And in the denominator, b is the base, and so q minus p, correct? So q minus p is the option D for you. So that becomes the answer for this particular question. Perfect. So I hope you have understood this strategy. Feel free to write your comment, share your views, and in case you want to learn from me, send an email. And success is what we can lead you to. Another brilliant question for you. Given log to the base 10 of 2 is equal to 0.3010 and log to the base 10 of 3 equals to 0.4771, we need to find the value of log to the base 10 of 48 and log to the base 10 of 324. The idea of the two questions is understand the concept, apply to solve the next problem so that you can always solve such questions. That is our learning process. Let's begin with the very first one, which is given to us as log to the base 10 of 48. Now we need to apply the logarithmic rules to break up 48 in terms of factors of 2 and 3. That's the whole idea, right? Some of you can do it very easily. We know 48, for example, can be written as what? It can be written as 16 times 3, right? Now 16 and 3 can be written as powers of 2 and 3. 16 is 2 to the power of 4 and 3 is 3 to the power of 1, correct? So once you know this, you can always write down the given expression as equal to log to the base 10 of these two numbers, right? So instead of 48, we are going to write as 16 times 3, right? 16 times 3, let's say like this, which is we can write log to the base 10 of, we can say 16 plus log to the base 10 of 3. So at this stage, we have applied logarithmic rule. So when we have a product, then it splits into the sum as shown here, which you are very familiar with. So now let's continue from here. We could write this as equal to log to the base 10. 16 is 2 to the power of 4 plus log to the base 10 of 3. 3 to the power of 1. Now we know the values of 2 and 3 log 2, log 3. So we can always figure this out, correct? So let's apply the power rule here, which will be 4 times log to the base 10 of 2, right? Plus log to the base 10 of 3. Now we can substitute both the values. Log to the base 10 of 2 is given to us as 0.3010. So it will be 4 times 0.3010 plus log to the base 10 of 3 is 0.4771. Correct. So moving forward, let's add these numbers, get the result, right? So what we get here is 4 times this number will be, we can have this as 4 times 0, 0, we get 4. Let's write 0, 4, 0, 1.2, correct. And to this, we are going to add 0.4771. So when you add them up, you get your result, which definitely is 1, 7, and 4, 11, 8, 4 into 6, 1.6811, right? You see how we found this value as equal to 1.6811. Makes sense, correct? So that is a strategy which is going to be adopted for solving such problems. So now you can always pause this video, answer what will be the value for log to the base 10 of 324. Now 324 is slightly bigger number. So to get the results, what you could do is split 324 as we did for 48. Now 48 was very simple number. Straight away we could find out two values which can give us a result. Now here 324, if you add 3 plus 2 is 5, 5 plus 4 is 9. That means 9 is a factor, right? And 9 is also a perfect square of 3. So we can write this as 9 times what? So 9 times 3 is 27, and 27 means you're left with 54, and that is 6. So once you write this, 36 is again 9 times 4, and you can further split this as 9 times 4. And now you could write 324 as powers of 3, right? 9 times 9 is 81, and powers of 3. So you could write this as log the base 10 of 9 square, which is 3 to the power of 4, right? Times this decimal is not a decimal, it's a product, and 4 will be 2 square. You get the whole idea, correct? And therefore, we can get the answer, which would be 4 times log of 3, right? There's no need to write to the base 10, because if you don't write anything, it means that the default value of 10 will be taken, plus 2 times log 2, correct? You are given the values of log 2 and log 3, substitute, get your answer. Perfect. So now I think you have understood completely how do we evaluate expressions when some values of logarithms are given to us. The idea is to split them into factors and then use what is given to us. I hope that makes sense. In our playlist, we have many such problems. Explore and learn with Anil Kumar. Now let's look into the solution of the question. If a square plus b square equals to c square, then find 1 over log to the base c plus a of b plus 1 over log to the base c minus a of b. We are given four choices, 1, 2, 3, 4. You can pause and answer the question. Now let us see a fast way of answering this particular problem. So look here, we really want to figure out what is 1 over log of c plus a of b plus 1 over log of c minus a of b. Change of base formula is something which you need to remember. So if I have log of, let's say, p q, we can change the base to q, for example. So it becomes log of q over log of q of p. So change of base to one of our argument, which in this case was q. So log of q is 1, right? And so we get here log of qp. So do you see one thing? We have a reciprocal kind of an identity here. Now this is a very useful identity which if you apply, you can answer this question within a minute. Perfect. So I hope you have understood this particular identity. And now it's very simple. As I was saying, you could actually rewrite this as log to the base b of c plus a plus log to the base b of c minus a. So you got the same base. Now once you have same base, you can apply the logarithmic laws. We have log to the base b of what? Multiply them, right? So c plus a times c minus a, which is log to the base b of c square minus a square, correct? So that is what we need, right? So we are given an expression where we have a square plus b square is c square. What is c square minus a square? And that is b square, right? So b square is c square minus a square, correct? From what is given. So we'll change this to b square and continue. Correct? So we get log to the base b of b square. And this is 2, right? 2 log to the base b of b, which is 2. So our solution is 2. Option B. Makes sense. So if you know this reciprocal identity, see how easy it is. Otherwise, it is extremely difficult question to work with. I hope you have understood this strategy. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting admission to the best universities. Thanks for your valuable time and all the best.